Thank you all for joining us for today's data visualization workshop. Joining us today is Hallie Burns from the UNLV Libraries, and I'm going to hand it over to her to get us started. Thank you.
Thank you so much. Hello, everybody. As was said, my name is Hallie Burns. I am the data librarian. I am also an assistant professor here at UNLV. Just a little background on me. I've been here about 2 years now, just coming up on that. I come here by way of Illinois, where I got my graduate degree and was studying basically data management, data curation, things like that. Just to let you all know that we're currently here at the libraries. Well, I'm currently doing virtual consultations for the time being. And so consultations for data services currently include information on data management, data manipulation, processing, visualization, as well as potentially any introductory questions you might have as far as Python, things like that. So let's jump in. Today we have a couple of learning objectives. We're going to discuss various methods of visualization and learn to assess visualizations. We're also going to identify when visualizations are being misleading and recognize data visualization tools that are free to use and available online. At any time, if you do have any questions, please let me know in chat. I'm happy to answer at any point. And with that, we are just going to get started with some introductory information here. So I want you to take a minute to write in chat what data visualization means to you. How would you define it? What is your experience with it? How have you used it? I'd like you just to take a moment and let us know. And I do have chat up on screen, so I'll just wait for a moment to get some answers here. Think of it as graph making in tables. Yeah, graphs are great ways to visualize your data. Charts and maps. Yeah, charts and maps. Analyze data in an easier form. Absolutely. And we're going to get into that in just a minute. I'm communicating your research visually to the reader. Yes, of course. These are really great answers. Thank you so much for indulging me. So, as we can see, data is factual information such as measurements or statistics used for a basis of reasoning, discussion, or calculation. This is just defining data to make it easier for us to then define data visualization. Data can be many things. It can be survey responses, code, measurements, recordings, collections of text. So before we jump into data visualization as a whole, I want to know, as a group, what kind of data do you work with? Do you work with numbers? Do you work with text? Do you work with measurements or images? Okay, wonderful. Work with images, coordinates, maps, things like that. What do you either currently work with on a project or have worked with in the past? Numbers and comparisons, great. Quantitative data, wonderful. Measurement statistics. We're seeing a really good variety here, which is awesome. Questionnaire responses and demographic data. Measurements, stats. Surveys. Wonderful, okay, thank you. So as you are all probably aware, there's a lot of different ways, as you've said, to visually represent different types of data. And as we can see on this screen here, data is defined as factual information. However, we need to be a bit careful because the data that's presented online sometimes can be misleading in certain ways. So I just want to quickly talk about how we can use data. So data can inform how we react to situations on a large scale, and it can be used to predict or prevent. So as we've seen over the past year and a half, things like COVID hospital data, different reports, things like that are able to help us decide as a state, as a country, as the world, basically, how we want to roll out testing, whether trends are getting worse, things like that. So data can help on a very large scale, but it can also help for day-to-day things. So for example, what I have here on the screen is something like weather forecasts, storm predictions. So knowing if you should wear a jacket or if your allergies are going to be really bad that day. Data can help you in a lot of small ways. However, falsifying data or extrapolating inaccurate information can occur. So it's just important when you're looking at data, when you're beginning to visualize your own data, you need to look at it with a critical eye. So, as many of you have already said, data visualization is some form of graphic representation of information and its data. So by using visual elements like charts, graphs, maps, tools can provide an accessible way to see and understand the trends and outliers that you have in your data. The key element of this, so if you take away anything from this, I want you to think that the key element of this is the idea of accessibility. Visualizations are supposed to make information and data, along with the patterns or the trends, more easy to comprehend, more easy to understand quickly by your audience. So it's to help broaden the understanding of everyone involved. So here on the screen, there's a couple of everyday visualizations, things like your phone battery, city maps, road signs, being able to see how much battery you have left, where you might be going on a map, or even looking at something quickly like a road sign and seeing, oh, I need to stop, or no U-turns allowed. These are elements of visualizations that we see every day. So I want you to take a moment and think about, feel free to write, or you can think about internally, examples of other common visualizations that you might come into contact with on a day-to-day basis. I can tell you, for instance, I happen to play a lot of video games, so things like my health bar is an example of a visualization that I frequently see. Even information on, say, my microwave can be a way of visualizing data. The downloading bar, yeah. The patient charts, the electric med records, absolutely. Yeah, these are all ways in which people are able to easily and accessibly see some information, process it, and know, oh, this is what this means. So visualizations can be very complex, or they can be things that we regard almost automatically and know. Could be calendars, yeah. Yeah, absolutely. Depending on how you make the calendar, absolutely. Even things on, I'm always coming back to icons. So like the power button on a computer or speedometer. Yes, absolutely. A speedometer could be. These are great examples. Okay. So now that we have an idea, now that we know we see visualizations all the time, whether it's in the news, on the computer, on our phones, day to day, when we're driving, we see them all the time. It's important to keep in mind that visualizations can be used to push an agenda or mislead an audience into believing a certain viewpoint. This does happen whether we like it or not, and I'm just going to have some examples here. And I want you to take a minute in chat to respond to what you think each of these examples might have that's misleading. So on the screen right now, why would showing someone this potentially be inaccurate or lead someone to a different conclusion? So I would say to take a look at the, yeah, it's unclear what the measures signify. Absolutely. It's just numbers and letters, and we don't know what that means. Is there anything else about this that might mislead? Visually shows incremental increases of question mark. Yes. It does appear to go up by 100 each time, but yes, you hit it on the head right there. It does not start at 0. So looking at this, not only is it not labeled, you don't know what things mean, but the axis does not start at 0. And because the axis does not start at 0, this effectively makes it look as though there's a bigger difference in these elements than there actually would be. If it started at 0 and went up to 10,000 per se, all of the things that you're seeing on the screen right now would ultimately appear like the same number. They would be very, very similar in height. But because you're removing that element, because you're shortening it, it makes it look as though there's a larger difference than there is. So just be aware, keep an eye out for axes that don't start at 0. This is another example of this, of showing you axes that don't start at 0. So it's making it look as though there's a very large difference between 108.6 million and 101.7 million. And obviously, numbers wise, yes, big difference. But when you're looking at it from a scale of 0 to like 200 million or something, relatively speaking, these numbers are very close. So when you're looking at things like that, such as welfare versus full-time jobs, Census Bureau things, just keep in mind that this kind of inaccurate or skewing of information can be used to try and convince you of something. Another example of potentially misleading visualization can be seen on this slide. I want to know, based on the left side of the slide, why might something like that mislead a viewer? Why might the pie chart over here, I think you can see my mouse, mislead a viewer? Item C looks much larger. Yes. Is there anything else? They just want people to focus on the 5%. There's the perspective bias, yes, and the side view makes it harder to see the percentages. Absolutely. So, as you all said, because it's showing you from a different perspective, it's making it look as though item D, because you can see that side view of it is a lot bigger than any of the other elements in the chart. However, as you can see on the right-hand side, that's not really the case. Item D and item B are actually the same size. Similar because item C is being pushed out because it's being shown to the front. They want people to focus on that. However, based on the angle that it's at, especially here on the left-hand side, it's hard to even know how much of a percentage that is because it's not listed. So make sure when you're doing color choice too, absolutely. The color choices are not the most accessible color choices, and they're occasionally very difficult to tell the difference between. So just make sure that when you are visualizing something, you want it to make sure that everything's on an even playing field. You want to make sure you're labeling something, and you want to make sure that you're very clear if you're looking at percentages, if it's a number per thousand, things like that. So legends, labeling, perspective. Keep all of that in mind. How about something like this? So this is a graph from Twitter looking at some kind of ratio. I don't remember what this is. This was pulled by a colleague several years ago. However, what might be misleading about this line graph essentially that we have here?
The grid lines are very white, and we can see exactly where it stands.
Yeah, absolutely. And yes, you are only looking at 3 months of data. So with the grids, it's also does not start at 0, I believe. Double checking here. No, it does not start at 0. The lines are wide, so it's hard to tell the very intricate numbers in there. There's no labels, correct? And also, you're only looking at a 3-month period. So this is what we call selection bias. Because, for instance, if you remember the graph on the previous slide, it looks as though trends are going up. But it's only from a 3-month point of view. So if you end up looking at this maximum, though, you can see that the trend over time is going down. So people will use this to cherry pick their data or select only a certain amount to show the argument that they want to show that something might be looking positive for this brief amount of time, but overall there's this downward trend. Here on this next one, and I promise we're almost done with these, this is an election map. We see these a lot. We saw these a lot over the last few years. What might be misleading about election maps? Looking at this, seeing the states, red versus blue, what might be misleading about this? Or what might not be telling the whole story about an election map? No labels of the Electoral College. Absolutely.
Yeah. Exactly.
It may differ by county. Yes. Yeah, so this is making an overgeneralization of how different people vote in the country. In that it's taking each state and taking the majority essentially and saying, this is how people voted. But if you really go diving deep, you would be able to see a much more fluid looking graph by county, by population density, how close the win-loss margins are not depicted exactly. It's very much what we refer to as an overgeneralization of data.
Yeah,
So you're not, yeah.
looks towards the size of the state instead of the size of the vote.
Mm-hmm. Absolutely, thank you. Yeah, so there's a lot going on with these election maps, and as you know, you've seen them on screen, on media, in the papers. Things like this are very common, but it's important to keep in mind that there's potentially more to the story than you're seeing. Let me just have 2 more here. This is just showing you a right versus wrong. Looking at total, especially when you're looking with something dealing with population, is not always the best way to go, particularly because you're not keeping in mind population density. And so for instance, if you are keeping in mind density or that certain things have a different percentage, suddenly you're having very different statistics than you're seeing here on the left. And then finally here, I want you to just take a minute and I want to know, looking at these two graphs here, if you had to display this information, would you choose the left graph or the right graph and why? Left's more concise, okay. The right has more information. The left is clearer. The right is more identifiable, okay. So this one is a bit trickier. So what you can see here, the right showing accurate numbers. Gotcha, gotcha, awesome. The right, first rounders of what? Exactly. So there's a lot going on with both of these, and obviously neither of these are perfect. The color choices are not always great. As you can see, however, hang on, let me go back. These are both examples of very common visualizations, the bar graph, the pie chart. However, this is also an example of how, depending on what kind of data you have, certain graphs might not be best for what you want to do. So for instance, as we've said, the left, people feel that it's most clear. However, the colors represented aren't necessarily the best. However, based on that, you can see, though, that the axes are labeled, the chart itself is labeled. You can see most players drafted in the first round, and then the places where they've been drafted. On the one to the right, while you can see the numbers, it's a bit more difficult to portray in a pie chart form because pie charts are usually used to show out of 100. It's to show a proportion of something. And while, yes, you can see the actual numbers here, it might be more helpful to use the percentage instead if you wanted to do something like that. However, yes, the logos themselves are potentially more identifiable. So this is just more of a demonstration to keep in mind that this can be a bit tricky, and that there's certain details that you might want to keep in mind as far as how people view things and what you want people to get out of the information that you are visualizing at that time. So just to go over what we talked about just now, there's a lot of ways that people can try to mislead, and we do see these pretty frequently. So just keep an open eye, look with things with a critical eye. People can truncate graphs, so not starting at the 0, 0 axis, making it look like there's a larger disparity than there is. They can distort the perspective, so bringing something more to attention that they want you to pay attention to instead of potentially showing you the full picture. Distorting the y-axis is also very popular, so once again showing that something is not necessarily starting from 0, or not showing exactly how numbers go up, as well as being selective about your data. So cherry picking your data, only showing something to push the narrative that you want it to show, as well as looking at the formats themselves. Not every visualization is right for every graph, so it's important to keep in mind what kind of data you have and what you want to get out of it, and we will be talking about that shortly. So before we move on to that part, I just wanted to show you these two resources. there's something called Data is Ugly, as well as the Reddit thread. No, the Reddit thread is Data is Ugly. There's something else called Data is Beautiful. Data is Ugly is a Reddit thread, and it will have submissions of different types of visualizations that are potentially problematic that people will comment on, take a look at, help each other figure out what's right or what's wrong about something. So it's very interesting to look at, and it's very cool to see, and potentially a bit scary to see how many types of inaccurate or misleading visualizations can really hit the media. And then Data is Beautiful, showing ways that visualizations can be very effective in telling a story and letting people know that information. So I do suggest checking those out if you have the time. So now we are going to jump into the meat of this lesson, which is how to build effective visualizations. So this is going to go back to a few ideas that is very helpful for you to keep in mind. You want to know your data. What I mean by this is it allows you, if you know what kind of information you have in there, if you know you're working with measurements, if you know that this column contains text, but this one contains numbers, it's able to help you identify inconsistencies a little bit easier, but it's also allows you to discover unique properties a bit easier as well. So on top of this, knowing your data also helps you identify what kind of visualizations might be best. There's the idea of exploration and analysis. So as we've said, visualizing your data can be an awesome way to present your findings at the conclusion of a research project. However, preliminary visualizations can also help you get a better idea or understanding as far as trends within the data, and it allows you to explore different hypotheses. So without that initial visualization, it might not have been clear from the start that there was something going on in that original data, something happening behind the scenes, such as an error or an outlier. So it can be helpful to do a preliminary visualization to get an idea of your data and how it flows and what information is there. And the last thing to keep in mind is to know your audience. So this means not just knowing who you're creating a visualization for, but also why you're creating one. What's the purpose? So you don't need to visualize something just for the sake of visualizing it, to add a pretty image to take up space. Visualizations can mean something. They can tell a story, and knowing your audience tells you a little bit more about what kind of story you want to convey. So for instance, a scientific visualization at a poster session is meant for a very different audience than, say, the health bar on your character in a video game or the power bar on your phone. So just keep in mind, know your audience, know who you're creating this for and what information you want to get across. So first things first, when you want to make a visualization, you want to think about two things. And one of the first things is, what is your goal? This is an example of a number of different goals that you might have, as well as visualizations that primarily are associated with those goals. So for instance, if you wanted to inform someone of something, convey important messages, you usually use text that stands out and it doesn't require a whole lot of information to understand. So visualizations that are meant to inform very frequently are things like infographics. They're just those quick images like traffic signals, things like that. If you want to compare something using pie charts, bar graphs, things like that, it's showing similarities or differences, seeing, yes, there have been this many purchases this month, but this many purchases that month, and we can compare those 2 months back to back. Your goal could also be change, so illustrating trends over time and space. This is very popular with timelines. You can also see this in different elements of like geospatial data when you have moving maps or different elements like that. You might also want to organize, show an organizational chart. So showing groups, patterns, ranks, orders. So on the screen, you can see the little triangle showing like top, this is the top of the pyramid. or it can be a hierarchy, so showing how something is organized based on the different options. You can potentially reveal relationships, so showing connections between data. On the screen, there's 2 examples of this, but there are many ways to show relationships between data. Or you might want to explore having the user or the reader actively interact with the data to discover the insights for themselves. So things like your more interactive, say, Tableau dashboards or things like that, where people can click on things and rearrange things and show a story that way, is more of potentially an exploration goal. Once you know your goal, though, you want to think about what kind of data you have. And as we said earlier, there's lots of kinds of data, whether it's images, text, readings from equipment. Here are a few examples of how you might break up that data. So it could be categorical, so data that's divided into groups. So for example, education level, sex, things like that. It could be data used for analysis. Oh, I wrote that wrong. Oh no, data used for exploration. So things like height, time, length, things that can vary across many different individuals. Then the idea of univariate, bivariate, or multivariate data. So data that can have multiple variables going on, such as correlation between temperature and ice cream sales. Or this could also include things like hierarchies. And then here is just, oh, bivariate, that's what I meant. So here's an example. For univariate data, you would most likely be using something like a bar chart or a pie graph. With bivariate, you're getting more into kinds of trees and scatter plots, showing that relationship in there. And then multivariate is showing relationships between multiple things. So there are many different ways that you can interpret that, and these are just some examples. Are there any questions about either defining a goal or the kinds of data you might have before I move on to the next section? I'm just going to give it a few seconds in chat. Okay. I'm not seeing anything. So next we're going to talk about visualization methods and popular tools. So there's a lot of different ways that you can take those goals and turn it into something concrete. So for example, infographics, geospatial data, network graphs, these are all common visualization methods. So for example, infographics are used primarily to inform. They're visual representations of data, usually with charts or images, minimal text, but they're meant to communicate information quickly and effectively and with ease. Geospatial data, I know some of you said you work with maps, so this could include interactive timelines or geo-based exhibits. This could include the work that people do with ArcGIS or QGIS, or things like story maps. And then network graphs, which you can see an example of a network on the screen there, showing relationships between items. So the circles being different subjects and the lines between them being the relationships between those subjects. So these are just kinds of common visualization methods that might exist. And because there are a lot of different methods, it's also important to know what kind of tools you have available. And there are a number of tools that you can get for free with either a subscription or here through the library. There's also a number that have public accounts, or for instance, as it says with Tableau, you can get what's called a student account, which gives you a license to use something through your student email address. Tableau, for those of you who aren't familiar, is a very powerful tool both for visualization and analysis. You can import data sets, you can bring, it can be even geospatial data sets, it can be tabular, and it allows you to create almost what they call dashboards, which allows you to show relationships between things and create almost an interactive experience to a certain degree. Then there's Canva and Venngage. Both of these do require the creation of an account. However, there are options in it that are free for use. Both of these are really great for infographics. Oh no, your free trial ended? Okay. I would suggest, if it did end, I would suggest either trying to renew the student one, or Tableau Public does have a lot of the same capabilities. There's just there's some caveats with it as far as publishing the content that you are creating once you saved it. So I would check into that. I'm not sure if we have Tableau on any of our computers, but I will take a look and see. So Canva and Venngage are both very good for infographics. So these, or poster presentations, or if you have to be in charge of social media accounts for anything, Canva and Venngage can be really great for both of these. What I like about them is if you are not as design capable, I am not very design capable, so they give you templates that you can use and adapt to your own devices. So instead of creating something from scratch, it gives you something that you can edit. After that is QGIS and Story Maps. Story Maps is an ArcGIS product. There are paid versions of it. However, with your UNLV email address, you can access a free version. And at least Story Maps allows you to create a narrative alongside different visual elements. These can be maps, videos, images, voice recordings. It can be interactive, or it can just be a display. So that can be very cool if you're working on, say, a project with historical content and you want to display both your data and your narrative at the same time. So having people scroll through, and then on the side there, having visualizations for it. Gephi and Cytoscape are also very popular platforms for network analysis, so showing relationships between data. They can be tricky to use depending on your experience. However, as I said, they're both free. You just need to download them. And then if you happen to be working a bit with text analysis or textual processing, tools like Voyant can be particularly helpful for helping you take large amounts of text and seeing the patterns within them. So just a couple of different options for different types of visualization that you might have in mind. In addition to that, there's also, if you prefer to interact more with hard code, there's programming languages. For instance, R and Python have a number of visualization packages, including Matplotlib, Seaborn, ggplot, Bokeh, things like that, that are available for downloading. So all of this information is available at the library guide that we have here. Is there anyone in the library to help with R? It depends on the kind of help you are looking for. So as far as helping you troubleshoot something, probably not. However, if you're looking for help trying to find a tutorial on something, or trying to figure out what kind of source you might need, there is the potential that I might be able to help you with that. I'm not as familiar with R as other programming languages, but I'd be happy to chat with you about what this specific question is, and we can see what I might be able to help with. So yes, ggplot2 is one of the visualization packages in R, and they do have a port for Python that I have not tried yet, but so this is a data visualization guide that we have here at the library. It walks you through the main visualization, well, some of the main visualization options, as well as as well as some text that might be helpful or resources that might be available to you. So Jupyter with Matplotlib is very lovely. I do love Jupyter. So before I release you today, I just want to show you really quickly one element of an open source software. This can be really good if you're having trouble with or trying to figure out what kind of visualization might be best for your project. I'm going to put a link to this in chat for those of you that want to look at this while I'm showing you this. It is something called raw graphs. I think I sent that to everyone. Yes, I did. So when you open up raw graphs, it's going to look like this. You can either download it for yourself if you want to go to GitHub and you're familiar with that platform, or you can use it through its web interface. I'm just going to select use it now. And you do have a couple of options here where you can paste your data, upload it, try your samples, grab it from a web page, or open a larger project that you might have. And to just kind of show you how this application might be helpful if you're trying to figure out what kind of visualization is best for you, I'm just going to look at try our data samples over here. And we are going to choose orchestras by musical instrument. So this is just an example that I particularly like. So you select it and it brings up the data over here, and you're able to look through this data, get to know your data a little bit over here. If it doesn't upload properly, you're given what's called data parsing options. So how your data might be separated, is it a column, etc. As well as if you happen to be working with dates, those can get a bit tricky, so it tries to help you out over here. What's cool about raw graphs is when you scroll down here to your different options. So you do have the ability to click through a number of different graph options on this website. And it will tell you as you click a little bit about the graph option itself. So what it could be used for, what kind of data it takes. If you do have any questions about that, they do have tutorials for creating each of these as well. But so for instance, if I wanted a bar chart, it's saying it shows categorical things, each bar is a category, and it's for quantitative dimensions. So this can be very helpful if you don't fully know exactly what kind of visualization you want to go into, but you do have an idea of what kind of data you're looking at. So for instance, let me look at my notes here. So we just chose the orchestra data set. This data set, I happen to know it is hierarchical. I know this because it said the thing on the data sample. So there are a number of things here that say underneath here, it's good for hierarchies, it's good for proportions, it's good for distributions or correlations, relationships, things like that. So I'm just going to show you pretty quickly how you might put something fast together to get an idea. I'm going to choose linear dendrogram for the hierarchies. It's going to say up here, it displays structured data with a tree structure, where the roots, so this here on the left side, and the leaves are on the right side. And then the size of each of these little circles can be customized a bit further. So that's all well and good, but you can scroll down here, and this is what's very useful about raw graphs is that you can then drag and drop the different types, the different columns that you have in your data into these options here, and it will create the graph for you. So it gives you that option to explore a little bit. So for instance, we're doing a hierarchy. Let's say that I want the variables to be group over here. So as you can see, that's been adjusted right here below it. And let's say that I want to do the instruments within the group. So you can see the leaves are getting bigger and bigger. You can see percussion, woodwind, string, brass, keyboards, and all of the different options under that. However, there's still some things that we can do here. If I want to customize the size, I can say the number. So however many times something shows up, what might I want that to look like? So over here, we can see something in strings is currently very, very popular. However, as you're working with graphs, labels are very important. So knowing exactly what that is up there would help you know and give you information about the visualization itself. So we're going to label that. Just drop the label here and we can see violins, both 1 and 2 are very popular within this data set. You're also able to customize the color here. So for instance, if something was showing up in a specific orchestra type, I could drop this here and now everything's changed colors. It also gives you the option to customize. So if you were working and wanted to put this on a website or something, but you need it to look a very specific way, you're given the option to do just some basic customizations that they have here on this screen. And then you're able to export it down here as a number of different types of files, such as an SVG file or a JPEG. So this is just very quickly kind of what this tool can do for you. It's really good for quick exploration. However, as was demonstrated, it's a bit limited on its visualizing capabilities. So if you wanted to have more customization, it might be best to get in here, figure out what kind of visualization is best for you, and then look at potentially one of those other options if you're looking for more customization, such as Tableau or Cytoscape, things like that. Raw Graphs is free. It is free to use. It's free to use. It's free to copy. And they do make a lot of different changes in this as it is currently still in beta testing, but it is free to use. And if you do have questions about it, they do have an about section that gives you a bit more information as far as like their timelines, how it can be used. As I said, what I also really like about it is it gives you tutorial options as well. So it'll tell you how to create each type of graph, which can be very good if you're experimenting and trying to figure out what's best for you. So I'm going to swap back to our slides just to finish this up. Once I remember present, that's where that is. So I know this was a lot of information, but in conclusion, visualizations are really effective ways to communicate information to your audience. You want to be careful with visualizations, particularly whether you're creating them or whether you're just viewing them, because they can be used to mislead. So be purposeful with your selections, make sure to use labels, and think that sometimes less is more. Remember that different types of data fit best with different types of visualizations. So if you're trying to do something super scientific, using an infographic might not be the best option. However, there are really great scientific infographics out there. And there are lots of different types and methods of visualizing data. There's so many programs out there. So if you do have any questions, we at the libraries are here to help. So as I said, we're currently doing virtual consultations. I personally do consultations pertaining to data management, manipulation, processing, some visualization stuff, as well as introductory programming. But if you do have any questions about anything else, feel free to ask me and we will try to get you to someone who'd be able to help you. So that concludes my presentation for today. As I said, I know that's a lot of information, so please let me know if you have any questions or feel free to contact me with my email address. I can just write that in the chat.
Well, thank you so much for sharing your time with us today, Hallie, and providing us with your expertise on this topic. We really appreciate it. And thanks to everyone for joining us. We'll see you at the next workshop.
Thank you for having me and nice seeing you all.